Hi. So now we can discuss a hypothesis test regarding two samples that are dependent, and we call those match pair samples. So it's going to be a little bit different, and in fact, we really can't compare the two. If it's a proactive like before and after type of thing, I cannot compare the before and after with the same subjects because the samples aren't independent, right? Because they're dependent upon the first sample, right? The after. So that means if I'm doing a study with acne medication where I'm taking pictures before, applying a treatment, and then assessing the subjects after they take the acne treatment, it is a dependent sample because I'm using every subject in the first sample in the second sample. But just like in common knowledge, though, like what do we look at? What is proactive in all those medications, even weight loss programs? What do they show on the TV and ads? They always show a before picture and after picture, right? And when we look at the before and after, what do we look for? Do we look for their hair color or their clothes? No, we look at the difference, right? If we look at proactive acne medication before and after pictures, we look at the difference between what their face looked like before having the treatment and after. If it's a weight loss, we look at the picture before the treatment of weight loss and then after, and we see, wow, they lost a lot of weight. So we tend just by common conversation, we say, oh, wow, did you see the difference? I'm going to try that. That's exactly what we do here. We look at the differences. So we're going to turn into a two sample hypothesis test looking at the difference and change, and then it's going to be a one sample t-test. So let's take a look. Okay, so we're going to go ahead and we have to make sure all the criteria are met, right? So we still say the sample, it comes from random sampling. We acknowledge that they're dependent and that the differences are normally distributed. Not each sample, but the differences are normally distributed. And we can go ahead and do that by just the regular criteria we usually use. And the samples are independent. So as you can tell, when we look at the test statistic and also itself, it's a little bit of work. We have to go ahead and take differences, then plug and chug, but you don't worry, we're going to have the calculator do all the work for us. So again, the same 5 steps as usual. The only difference is we're going to go ahead and look at the differences. And then because we're taking a two sample mean test with with a dependent sampling, we look at the differences, turning it into a one sample t-test regarding the differences. So that's why notice that you'll want to mark this and also highlight it on the formula sheet because even though it's two samples, you determine if they're independent or dependent. And if they're dependent, it turns into a one sample t-test because you're looking only at the differences. Okay, so with this is a little bit of inequality stuff. So for example, the status quo is always going to be the status quo, right? So the difference is we call it mu sub d, right? D for difference is equal to 0, meaning there's no difference. As usual, right? Well, this comes from if we look at the null hypothesis just like that, like usual, right? We would say status quo, there's no change, right? If I move mu sub 2 over to the left, notice I get mu sub 1 minus mu sub 2 equals 0. Let's say I decided I wanted to move mu sub 1 over to the right. Well, that's going to be mu sub 2 minus mu sub 1 also equal to 0. No matter what, these two differences, mu sub d, is still equal to 0, right? Just with simple like arithmetic. Well, let's look at the test statistic. I mean, sorry, the alternative. So the alternative can be where the difference could be greater than, less than, or not equal to, right? 0. So we just have to be careful when we're doing a right and left tail test, because when we are doing that left and right tail test, we have an inequality symbol, and we do have some criteria when we start doing inequalities, right? And so just like we have these cases here with the differences and moving over the mean to the right or to the left, that will change your inequality symbol, right? So let's take a look at what that looks like. So let's just say I have mu sub 1 greater than mu sub 2, right? I think before taking the acne medication had increased acne than after taking the acne medication, right? So let's say mu 1 is greater than mu sub 2. Because they're dependent sampling, I can only look at the differences. So let me subtract. So I either can subtract, it goes in two cases. So I either can subtract mu sub 2 over to the left, and I get mu sub 1 minus mu sub 2 greater than 0. Then I have the case where I'm like, no, I'm going to move mu sub 1 over to the right and get mu sub 2 minus mu sub 1, and that stays like that, right? And then 0 on the left side. But let me rewrite it for you. So where mu sub 1 minus mu sub 2, remember that it eats the larger number always, so the greater than is open at the 0, so looks like that. So what just happened? Notice when I moved mu sub 2 over to the left, I got mu sub 1 minus mu sub 2 greater than 0, right? So this has become a right tail test. When I moved mu sub 1 over to the right side, I got 0 greater than mu sub 2 minus mu sub 1. But if I put 0 on the same side on this right side, and it eats the larger number, it's mu sub 2 minus mu sub 1 less than 0. And therefore, it becomes a left tail test. So what this means is you need to be careful in where you're subtracting things. Okay, you just can't say, oh, I'm going to subtract here, subtract. No, wherever you subtract, your means determines your test. I encourage you to always subtract mu sub 2 to the right. And that way you won't have any sort of, just get used to every mu sub 1 always being on the left. Get used to the left side. I think list 1 will be on the left side, minus list 2. It just goes in the order of your problem. So in your calculator, you're going to have list 1 minus list 2. If you have mu sub 2 minus mu sub 1, this becomes list 2 minus list sub 1. But I encourage you to have, I encourage you to do list 1 minus list 2, and just keep it that way. So here, let me go ahead and do now mu sub 1 not equal to mu sub 2. And you'll see it's similar as the equal sign, because it wouldn't matter which way we subtract. We still get not equal to 0. Right, and so this is two-tailed. So really what we're worried about here is the left and right tail. So wherever you subtract, keep it clean. Keep it clean. List 1 is list 1, mu sub 1, mu sub 1. Align the subscripts, okay? And do list 1 minus list 2, and then always keep the sign of the inequality. Okay, so how do we do this? So in the calculator, what we're going to do is we'll go to our calculator, and we're going to put before in list 1 and after in list 2, or subjects in the first sample, subjects in the second sample. Then, because we're taking a two dependent samples with hypothesis testing and only looking at the differences, it becomes a one sample t-test on the differences. And therefore on list 3, we're going to put the differences. And then we just go ahead and go to stat and go to test and go to the t-test on the differences. So we have to be careful here.